name is Brooke Ridley, and I'm a student in Dr. Seeger's Engineering Business Practice class. I will be discussing the topics of present value and annual worth and providing an outline solution for an FE exam problem. Present value is defined as the current worth of a future sum of money or stream of cash flows given a specified rate of return. These future cash flows are discounted at the discount rate. The equation for present value is shown here. This equation includes F, the future worth, value, or amount, I, the interest or discount rate per interest period, and N, the number of compounding periods. This is the equation for present value when calculating one payment at a time. If a uniform amount is being applied over multiple interest periods, the recurring payments can be lumped into one equation as shown. The F term is substituted for the A term, which is the uniform amount per interest period. This speeds up calculations of the present value when recurring payments are occurring over numerous compounding periods. Net present value is defined as the sum of the present values of incoming and outgoing cash flows over a set period of time. The equation for net present value is just the difference between the present value of cash inflows and the present value of cash outflows. Annual worth is defined as the cost per year of owning and operating an asset over its lifetime. This equation includes P, the net present value over the compounding periods, I, the interest rate or discount rate per interest period, and N, the number of compounding periods. The question we will be looking at involves a contractor who is looking to buy a piece of equipment, and the contractor is trying to determine whether or not buying the equipment will be worth it. So the question states that a contractor wants to buy a piece of equipment to use over a 10-year period and then sell it. The equipment costs $25,000 and generates $8,000 per year. At the end of this 10-year period, the contractor sells the equipment for a salvage value of $3,000. Using a discount rate of 3%, how much money will be made or lost at the end of 10 years? What is the annual worth of this equipment? So first we will construct a cash flow diagram for the lifetime of this equipment. A cash flow diagram presents a graphical representation of the timing of cash flows. Upward arrows indicate positive cash flow, and downward arrows indicate negative cash flow. The initial cost of the equipment occurs in year 0 at $25,000. Every year for the 10-year period, the equipment generates a consistent $8,000 in profit from year 1 to year 10. At the end of year 10, the contractor sells the equipment for $3,000. Therefore, the total cash flow in year 10 is the difference between the profit and salvage value, which is $5,000. After the cash flow diagram is drawn, the net present value of the equipment over the 10-year period is calculated. This is done by calculating the present value for each cash flow. In year 0, the cost of the machine is $25,000. The equation for present value can be used. The value in red is the initial cost of the equipment, the value in blue is the discount rate of 3%, and the value in green is the number of compounding periods. This results in a present value of $25,000 at year 0. This makes sense because present value is evaluated based on time 0. In order to calculate the net present value, the present value of each cash flow must be calculated. Since the $8,000 value occurs over 10 years, the present value equation for recurring payments can be used. This shows that payments of $8,000 are occurring over 10 years at a discounted rate of 3%. This results in a total present value of about $68,242. Now the present value of the final salvage price must be calculated. The single payment equation for present value will be used since the salvage value occurs once at the end of the 10-year period. This results in a total present value of $2,232. The net present value can then be calculated by summing these three present values. The initial cost is the only negative cash flow, so this will be subtracted from the sum of the other two present values. This results in a net present value of $45,474 for the equipment. Therefore, the equipment is profitable for the contractor. Now the annual worth of the equipment will be calculated. This will be done by using the equation for annual worth that was present earlier. The net present value of $45,474 is in red, while the discount rate of 3% is in blue and is being compounded over a period of 10 years in green. This results in a final annual worth of $5,331. This means that the contractor will be making an annual worth of $5,331 per year for 10 years if the profit is dispersed evenly over the 10-year period. So should the contractor invest in the equipment? Yes, the contractor should invest in the equipment because it is profitable, with a net present value of $45,474 and an annual worth of $5,331. Therefore, the contractor would be making money off of the equipment over the 10-year period.